Okay. Sorry. So if I remember correctly, in the last class, we were discussing about the types of chemical reactions, right?
Yeah,
The first one was, what was that? The combination
single,
reaction. That's combination reaction. Okay.
yeah,
Then decomposition reaction, and then single displacement. Hello.
regress.
Oh, no issue. Yeah, so the combination reaction where two or more reactants combine to form a single object, we call it combination reaction, correct?
Yeah,
And then decomposition reactions where one product decompose it, means break it into different reactants called decomposition reactions. And the third one was we were discussing about the single displacement, right? Single
yeah,
displacement reaction where one element displaces the other element from the compound. In this type of reaction, we call it single displacement. And in double displacement, there are two displacements. So the elements from the compounds interchange their ions. We call it double displacement, right?
yeah.
Okay, so today we'll discuss about one important thing. We call it combustion reaction. Hmm. Okay, so you can write along with me, be better to understand. So today we will discuss the combustion. Okay, what is combustion? Any idea?
It, when it's the scientific name for burning.
Exactly. So combustion is nothing but it is a chemical reactions when substance, generally fuel, right, reacts with oxygen to release energy in the form of heat and light. Okay, like
Yeah,
fuel burns. The burning of fuel is called combustion. Understood?
okay,
So right.
yeah,
So you can write like this. So it is a chemical. It is a chemical reaction. It is a chemical reaction where a substance, usually a fuel, reacts with oxygen to release energy in the form of heat and light. What was the product of that chemical reactions?
uh, heat and
No,
light.
yeah, that is the main, that is the, you can say one of the product you can say, but the main constituent of any fuel is carbon and hydrogen. Okay, like
The chemical reaction, the fuel plus oxygen,
yes.
like air,
Hmm.
carbon dioxide plus hydrogen.
Not the carbon dioxide plus hydrogen, carbon dioxide plus water, H2O. Okay,
Water.
because fuel has carbon and hydrogen as both. Okay, so that's why we call it hydrocarbons.
Okay,
So fuel, we also call fuel as hydrocarbon. So hydrocarbon means it has a carbon as well as hydrogen. Okay.
say the formula is
There are
fuel plus oxygen
yes,
will form carbon dioxide
yes,
and water.
yeah. So fuel plus oxygen gives you carbon dioxide plus H2O plus energy. Right?
Yeah,
Fuel is also called hydrocarbons. Hydrocarbons. Hydrocarbon means it contains hydrogen and carbon. Okay, any kind of fuels like do you know any types of fuels?
so
What is fuel?
like a non-renewable type of energy.
Uh, yes, okay, but name the fuels. Any? Do you know any names?
Uh, natural oil,
Natural
crude,
oil, yeah. So it's like uh, petrol, right? You know the petrol?
yeah.
These,
Wait, is fuel basically a hydrocarbon?
yes, it is a hydrocarbon. So hydrocarbon means it has carbon and hydrogen.
Okay,
So when carbon burns, it will form CO2, right?
yeah.
And hydrogen burns, it creates,
When hydrogen burns,
yeah. So H2 plus O2 is what is that? H2 plus O2. Burning means it is a reaction with oxygen.
water.
Yes, so that's why you can see in this reaction, it's a fuel plus O2 equals CO2 plus H2O, and then energy is there. Okay. Is wood is fuel?
Fuel
Wood.
and
Wood.
energy source.
Yeah, is it a fuel? Because we can we call it fuel? Wood?
Uh,
Yes, we can say, we can say,
yeah.
but it is not conventional fuel. It is the non-conventional fuel. Okay,
Okay.
good. Then next we'll write. So what is the main product of this combustion reactions?
Carbon dioxide and water.
Great. So you can say the product of combustion reaction are typically carbon dioxide and water. Okay. So the main product of the combustion reaction is carbon dioxide and water. Okay. What is fossil fuel, Lohit?
A non-renewable type of energy.
Yes, renewable and non-renewable. I didn't get it. What is that?
The non-renewable is when it can't get replaced. So every time it seems to run out, and renewable is it will stay there forever.
So it is kind of rechargeable. Renewable is a kind of rechargeable, right?
Yeah.
It can recharge, but you cannot recharge the non-renewable energy sources. What is that do you know any non-renewable energy sources? Like fossil fuels, right?
Yeah.
Why we call fossil fuels? Do you have any idea?
Because they were made millions of years ago.
What is fossil? What is mean that? What is the meaning of fossil?
It's like stuff from million years ago, like stuff buried
Yes, very
in the
good.
ground.
And due to like in during million years, due to pressure and temperature, the high temperature, high pressure, it convert into fuels. That's why we call it fossil fuels. Understood?
Yeah,
Yes. So write that. So the types of fuels we will write. The first one is the fossil fuel. Example. Can you give me any example? So it is like
oil.
oil. Very
Yeah,
good. Oil. All the oils. Natural gas.
yeah, coal.
Natural gas, coal, great, and etc. Right?
Yeah,
This is non-renewable non-renewable energy source, right? So it
yeah,
is non-renewable energy source, means which cannot recharge easily, or you can say mathematically it can be done, but we have to wait for next million years, right?
yeah.
So you can say like practically it is non-rechargeable. Practically it is non-rechargeable. And as we have seen, the burning of fossil fuels creates what? Produces what?
Carbon dioxide and water.
Very good. So you can write fossil fuels produces carbon dioxide and other greenhouse gases. You know what is that? Greenhouse gases?
Yeah,
What is that?
it's like gases that go to the atmosphere.
Yes. And greenhouse gases.
And they do something called the greenhouse effect.
What is that?
When, for example, if we use lots of cars that produce lots of methane and carbon dioxide, and that goes up in the atmosphere, where it comes with the comes in contact with some rays, some is scattered into space, but others is others is like coming back down to Earth, I think, and it heats up the atmosphere,
Good.
making it hotter.
But have you heard that the due to this global warming or something like greenhouse gases effect, the world might freeze as well.
No, no, oh yeah, because if we stop using fossil fuels, the Earth will freeze again.
Okay, let me explain you. It is very, very good concept. Like people understand that the greenhouse effect only heats up the earth. It is not like that. It can heat as well as at the same time in the next cycle it can freeze the earth as well. You know why?
Yeah.
Huh.
I don't know why, but there's two theories of it.
Yes, yes. It is very simple, straight and straightforward theory. See here, see my screen. Okay. So let's say this is your earth. Okay. And sun is there. Okay. So greenhouses gases are there. They are very heavy gases. So they are very close to the atmosphere, very close to the surface of the earth. Okay. So let's say these are the gases. Okay. So what happened when the lights are coming and striking the earth's surface? when it is reflected through from the Earth's surface, it is not going out. It is that light is absorbed by the gas here near the surroundings. Okay, that's why it heated this surroundings of that Earth. So that's why the heating effect is there. Okay, that you know, right? But
Yeah.
what happened when, like, every time sun is not here, right? In the next season, when it is a winter season, right now it is there, right? In your location. So in the winter season, sun is somewhere there. It is little far from this location. Okay. So in that case, what happened? The same thing will, this same gas will try to prevent the gas from coming back to the earth. Okay. So the gas will try to you can say arrest the light coming from the earth, because that is very weak, because it is coming from very long distance, right?
Yeah.
So that light is not able to reach the surface of the earth. So in that case, that will freeze. We are alive because of the sunlight, you know. We are alive
Yeah.
because of the sun. We are the energy we are getting from the sunlight. If there is no sunlight, everybody will freeze. Okay. So the greenhouse effect is not only to heat the earth, it can also affect the cooling of the surface of the earth. Understood? So there are both the effect can be done. Okay. So I'm just deleting it. You should know these things. That's it. So the burning of fossil fuels produces carbon dioxide and greenhouse gases. Okay, so that's why it is not advisable to run more number of cars on the road, because it will run on the petrol, it will burn the petrol, it will run the natural gas, it will burn the natural gases, and that will create more carbon dioxide, more greenhouse gases, which eventually affect our surroundings. Understood?
Yeah.
Very good. Now, the first one is the fossil fuels, which is also called non-renewable sources, and the second one is called renewable sources. You tell me any renewable fuel.
Solar, wind,
Very
hydro.
good. Very good. Have you heard about the biofuels?
Yeah.
What is that, biofuels?
I didn't know, but I heard of it.
Okay, actually, no, the biofuels is nothing. It is simple, like petrol only, but it is a mixture of petrol, the gasoline, and some other biological, I mean, like edible oil, like methanol. Okay,
Okay.
so that creates less amount of carbon dioxide. So renewable fuels is examples we can say is ethanol. Even hydrogen also comes under renewables, renewable fuels.
Wait, is there any reason that people didn't use it? It's very flammable.
Which one? Hydrogen?
Yeah.
Yes. That is one of the reason, but it is very difficult to produce also. Very expensive also. It is very expensive to produce. Otherwise, it is very, very good fuel. You know, what is the product of that if hydrogen burns? Hydrogen burns, what would it create? What is the product of if hydrogen burns?
I don't know.
You can write directly, right? Hydrogen. See here. Hydrogen plus oxygen. What was that?
Water.
Water. So the product is water. So there is no harm on the atmosphere, right?
Yeah.
So now your question should be like, why people don't use this one? We can. Even one hydrogen car is also running on the road of the Germany.
Okay.
But it is very, very difficult to make. It is very, very expensive to make. Okay.
Okay.
Yeah, so what does it mean? Renewable means renewable source of fuel means these can be produced again and again.
Okay.
Again and again. As many as we can. As many as we want, like from the sugar cane, from algae, different sources are there. Like from sugar cane. So ethanol, we can produce ethanol from sugar cane. Have you seen the sugar cane?
Yeah.
Very good. Okay. Hope you have written this, some of the things.
Yes.
Very good. Now, so equation of combustion, what is that mean? So we can write word equation of combustion. So like methane, it is also called natural gas, right?
Yeah.
Natural gas burns with oxygen to produce carbon dioxide and water. Burns with oxygen to produce carbon dioxide and water. So you can write like that, methane plus O2. I mean oxygen I should write because I'm writing in word form. So oxygen will give you carbon dioxide plus water. Give me some real life examples of combustion.
Matchsticks.
Combustion means, what is that combustion means? Combustion means it is chemical reactions where fuels burned with oxygen produces carbon dioxide, water, and the energy. The main reason while burning to burn anything is to get the energy, right?
No, but if you like a matchstick, won't you also create energy,
So
like thermal energy?
yes, okay, I understand. Any other example? Like car engines, right?
Yeah.
Car engines where we burn what? Where we burn fossil fuels, right?
Yeah.
To get the energy, right?
Yeah.
So let me give you some real life examples. So in school, it is the holidays, right?
Yeah.
So what are you doing whole day, Lohit?
No.
Just game, huh? Game.
Huh?
Playing games?
Um, Sometimes.
Online games?
Yeah. And
Uh,
sometimes. It's too dark for me to go outside the rest of the day.
okay, but you don't play any outdoor games?
I do, but it's too dark outside today.
Okay. Okay. So even in the UK, the dogs are there, huh? And they're creating problem for you, huh?
What?
You're talking about the street dogs, huh?
It's dark.
Okay, dark, you're saying. Okay. No, but in the daytime I'm asking, not right, not like that, not right now.
In the day,
Hmm.
it's not dark, but I have to study in the day.
Uh, but whenever you get free time, it is already dark outside, right?
Yeah.
Generally, you woke up at 11 or what?
Uh,
11?
yeah.
11? At what time you woke up in the morning?
I think it's at 12 or 11.
11? And nobody tells you anything?
No, it's the holiday. Yeah, I still study, but I sometimes wake up at 11.
Oh my God. So you are not getting, you're not taking your breakfast every day, right?
Yeah, I
So,
did.
so like if you're taking breakfast at 11 or
Sometimes
12,
I did.
then there is no lunch. Huh?
Sometimes I did eat breakfast.
Hmm. And nobody is telling you because it is a holidays. Nobody is calling you because it is a holidays, right?
Yeah.
So you are now an independent person. I don't say boy, it should be a person, right? So you are in year 8, right? Or 9?
Yeah.
8.
Hey,
So next year September you will be in 9 or in July.
you what?
In like next year in September or in you will go to year 9, right?
Yeah.
September.
Yeah.
It's been too long. Okay. So I was talking about the real life examples. So first one we can say the car engines, where petrol and diesel are fossil fuels used in car, right?
Yeah.
And where we do this cooking as well, right?
Yeah.
Okay. For cooking, which gas we use? Which gas?
Petrol.
Petrol. Petrol. We use your mother used
Oil.
petrol.
Oil.
Hmm. I I
Oil.
mean I mean fuel. I'm talking about the fuel.
Uh,
In for the cooking, your mother used something to burn, right?
yeah.
So what? Is it petrol or diesel or what? What fuel she is using in the kitchen?
Hydrogen.
Hydrogen?
There. 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 I don't know.
Gas, right? Gas cylinder is there, right? Gas is coming through pipeline or what?
Gasoline.
Gasoline.
No. I
No.
don't know.
Gas, petrol. You know petrol?
Yeah.
So gasoline is like petrol is also called gasoline. So gasoline and petrol is same. Okay.
Oh,
Okay. So you don't know which fuel your mother use in the kitchen. Eh?
no.
Now, gas is right? Gas.
Natural gas.
She must have, yeah, she must have one stove, right? The gas stove.
Yeah.
Have you have you ever entered in the kitchen?
Yeah.
Have you seen the stove? Gas stove?
Yeah.
Yes. So for that stove, we need a fuel, right? Or gas, right?
Yeah.
So it's a natural gas. Understood?
Yeah.
And don't say next time the petrol, we are using petrol to cook.
Okay.
Okay. So for cooking, we use this. What the third example?
Um.
Do you use room heater?
Sometimes.
Okay, so in for the room heating as well, people generally used this natural gas heaters and something. Okay, so for the room heating as well. So room heater for the room heating. Any other example can you give me? From where did you get
And
this electricity? Electricity is there, right?
yeah,
From where you are getting this electricity?
from the nuclear power plant.
Exactly. So there also the combustion is there or what?
Yeah,
Yeah. So in the power plant as well. Very good. Any other example? Candle burning is also a fuel burning, right? A chemical reactions,
yeah,
right? So that is also, you can say, if you're burning a candle, it will also release some energy. So you can write candle burning as well. You have to remember all these things. I will ask in the question in the last. You know that?
yeah.
Yes, you should remember. Next time, don't tell me that you are using gasoline. Otherwise, I will ask you to eat gasoline only in the lunch. Have you smelled the gasoline, Lohit?
Yeah,
It is very harsh, right?
yeah.
Good. Oh, which kind of any other petrol, any other fuel which is used in cars other than gasoline?
Diesel.
Diesel, right? Very good. These are all hydrocarbons, these are all hydrocarbons, as well as it has nitrogen as well. So
Yeah,
carbon, hydrogen, nitrogen, sulfur as well. Okay. So carbon, hydrogen, nitrogen, sulfur, many elements are there in that fuels. That's why when it burns, no, it creates carbon dioxide, sulfur dioxide, which is very harmful. Nitrogen dioxide, it is also very harmful. Understood?
yeah.
Hmm. Now we'll talk about the future fuels. Can you please name any fuels that can be used in the future?
Wind.
Wind, yeah, right now we are also using wind now as well, right?
Yeah,
Yeah, all renewable energy is the future fuels. Okay.
yeah.
Yeah, so something like hydrogen we can used again, ethanol. Okay, so now car don't runs on only on gasoline. It's a car nowadays. Car runs on the mixture of gasoline and ethanol. Okay, we call it biogas, biodiesel, biopetrol. Okay, you right now. What are you doing?
The future fuels.
Future fuels.
The hydrogen and ethanol.
Yes.
Okay. And the
Very good. Mhm. Okay. So let me see if there is anything in the fuels. So all renewable sources, I mean fuels are those all renewable source of energy are the future fuels, right?
Yeah.
Hmm. Hmm. Okay. Okay. Now we'll discuss the thermal decomposition. Thermal decomposition. Next chapter. It is thermal decomposition. What is that thermal decomposition?
It's when one product breaks down into different products.
Very good. So thermal decomposition is nothing but it is a decomposition of any product. So it is a chemical reaction, you can write. It is a chemical reaction. You can write along with me. Okay, chemical reaction where a single compound breaks down into simpler substances. When a single
It breaks down into simpler substances.
yes, single compound breaks down into simpler substances.
Okay.
So, like what we have seen combustion. Combustion, what was the main product of combustion? Why we do combustion? Why we do combustion? To get the energy, right? To get the energy, right?
Yeah.
Yes. Now here it is reverse. Here we are doing the thermal decomposition means we are decomposing the product, one product into different substance. I mean one substance into different substance. So for doing that, we need to give the thermal energy. Okay. So here we are giving the energy to the system. In the previous one, we are getting energy from the system with the reactions. Understood? So in the combustion reaction, we were getting the energy from the reaction. But in thermal decomposition, it is a reaction where we have to give energy to do the reaction. Understood? So that is the difference.
Yeah.
That is a completely reverse. Okay?
Okay.
So in that case, heat energy is required. You should be very careful. Like you have to be very smart to differentiate between these two. So in combustion, the main product is energy. Product is energy, but in thermal decomposition means we have to give energy to the system to break down into small substances. Understood? So, so heat energy is required. That's why it is called thermal decomposition. Thermal means it is related to temperature. I mean heat is required to break the chemical bond. In the compound. And it is also irreversible process. You cannot reverse it back. Done?
No. The
Okay. We'll give some of the examples of the thermal decomposition. So examples are the decomposition of hydrogen peroxide. So hydrogen peroxide decomposition. What is hydrogen peroxide formula?
H.
Hmm.
Uh,
Hydrogen peroxide.
uh, I don't know.
H2O2.
Okay.
It is H2O2. Okay. So when we heat the H2O2, I mean hydrogen peroxide, it converts into, or you can say it decomposes into water and oxygen.
Okay.
You have to write like this. We have to give heat. You see here how to write. See, here we have written heat, means we are giving heat to this. It is, and it produces water. I mean H2O. I should write like this chemical name. It produces H2O and oxygen.
Okay. Then
Done, right? Very good. Another example, you can write one more example if you want. It's a copper carbonate decomposition. Copper carbonate.
what? CCA4.
It's not CA4. It is CaCO3.
Yeah.
CuCO3. Carbonate is CO3. Carbonate is CO3.
Oh, CA4.
No,
Wait, one second.
no, that is SO4, sulfate.
Okay, wait, one second.
So copper carbonate, you can write copper carbonate. Copper carbonate.
Notice.
You got the formula?
Uh,
Okay. So
yeah, I got it.
carbonate is always CO3. Okay, either it is a calcium carbonate or copper carbonate. Okay.
Okay.
So when you heat the copper carbonate, it decomposes into copper oxide and carbon dioxide. So it is CuCO3. When you give heat, it breaks down into copper oxide and CO2.
Yeah. Okay. Done.
Good. Just let me check what is given in your book. So magnesium nitrate is also there. So magnesium nitrate. So the third option example we can see the magnesium nitrate. Can you tell me the formula for that magnesium nitrate?
MgNA3.
Not always like that. So it is MgNO3 whole twice.
What?
MgNO3 twice. It is like
There's
Mg.
two MgNA3.
It is like this. So it is magnesium nitrate. Okay.
Okay.
Because magnesium has 2 electron at the outermost cell. That's why 2 is coming here. Okay. Or and nitrate has only 1 electron outside. So that's why only one he is coming here. That's why it is MgNO3 2. Understood?
Yeah.
So that's why the compound forms like that. It is not randomly like if nitrate is there, it is MgNO3, CuCuNO3 or something like that. It doesn't form like that. It depends upon then the number of electron in the outermost orbit. Okay?
Okay.
Good. So magnesium nitrate, when you heat that magnesium nitrate, it decomposes into magnesium oxide and obviously, just wait, and sodium, I mean nitrogen dioxide. So it is magnesium oxide, MgO plus NO2, nitrogen dioxide. So MgO plus NO2.
Okay. The Mg plus Mg.
Yes.
Na2.
Yeah, NO2, nitrogen
Okay.
dioxide.
Okay.
So to,
Done.
for the this thermal decomposition, we need heat to break the compound. Understood?
Yeah.
Very good. So it is just a reverse of combustion. In combustion, generally we receive heat, but in thermal decomposition, we have to give heat to break down.
Okay.
So this is the main difference between the thermal decomposition and this, I mean, this combustion. Strontium nitrate. One more is there in your book. I'm just writing. Okay. It is also in the questions. So it is what happened if we do the thermal decomposition of strontium nitrate. So
Okay.
strontium nitrate decomposition. You can write very important thing. Maybe it will come in the examination. So strontium nitrate decomposition. So strontium is Sr. So Sr NO3 twice again. This is the formula for strontium nitrate.
Okay.
What happened when we give heat to that? Again, it creates strontium oxide, SRO, strontium oxide plus NO2. So what is the product? Strontium oxide.
Is that SA plus NO2 or is that SRO plus NO2?
SRO plus NO2. So it is a strontium nitrate, strontium oxide and nitrogen dioxide. These are the two product form if we decompose the strontium nitrate.
Okay.
So you have to remember these things. Will you remember?
Yeah.
Yes, that is very important. Now I am just reading the question. You have to complete the fill in the blanks. Okay. Listen carefully. In a decomposition reaction, a single dash, you have to fill a single dash breaks down to make dash compounds.
A single compound
breaks down to
breaks
make
down or
to make
to make simpler compounds.
very good. And the elements okay, the copper carbonates decomposes to make dash oxide and dash dioxide gas. Copper carbonate decomposes to make dash oxide to dash dioxide gas. Shall I repeat again? So listen. Copper carbonate decomposes to make, are you listening, Lohit?
Yeah.
Copper carbonate decomposes to make dash oxide and dash dioxide gas. Copper carbonate.
Copper oxide
and
carbon dioxide.
Very good. Next, hydrogen peroxide decomposes to make water and dash gas.
Hydrogen peroxide decomposes to make
water
and oxygen.
Very good. Water or oxygen? Water or hydrogen? Water or oxygen? Just now you have seen the first example, Ray. You see,
I forgot that on the board. Yeah, water and oxygen.
Right?
Yeah.
So these things you need to remember. Okay. Okay, so we will finish today's. Next class we'll discuss, the conservation of mass. Okay.
Okay.
Okay, then bye-bye.
Bye.